Students, I'm Sonali Kerkar from City International School, and today we are going to start the new chapter of physics, that is Human Eye and the Colorful World, part 1. So in this session we are going to study about refraction of light through prism, dispersion of white light, recombination, rainbow formation, and questions and answer. I want you all to do these question and answer in your notebook. So let's start with the topic prism, right? So let's take a prism. Have you ever seen the prism? Okay, now let me describe some characteristic of prism, right? So prism, as you can see, it is made up of three lateral faces. You can see these are the three triangles and the three rectangles and two triangles, children. Okay, it is made up of three rectangular faces and two triangular faces, right? So this is what is a prism. There are different kinds of prism, children. This is the one that we are going to use for this chapter, right? In this chapter, so a triangular prism has two triangular bases and three lateral rectangular surfaces. As I've showed you here. Now these bases, okay, the surfaces are inclined. You can see this surface and this surface, the two surfaces, right? These two surfaces are inclined at an angle of 60 degree to each other. Children, here we are talking about particularly triangular prism. So these configuration, they are for the triangular prism and not any other prism. Clear? So okay, these surfaces are inclined to each other. As you can see, let me mark it as F1. Okay, this is the face 1, and over here F2, right? So F1 and F2 are the two faces or the two surfaces of this triangular prism. Clear? And as I told you, it has the angle is 60 degree. Okay, this angle is 60 degree. These two surfaces are positioned at 60 degree, right? And this is known as angle of prism. Clear, students? So the surfaces are inclined to each other. The angle between its two lateral faces is called angle of prism. Now the opposite faces, as you can see here, the opposite faces, face 1 and face 2 are the two opposite faces, right? These two faces, are they arranged parallel? Are they arranged parallel just like your rectangular slab, glass slab? No, they are not arranged parallel. Why we are teaching why I'm teaching you about these two surfaces in detail? Because that is the reason why the white light get refract. Okay, now let's see the first phenomena which is going to affect by these two surfaces, right? If I pass a ray of light through this prism, right, and this ray of light is little bit inclined. This ray of light is little bit inclined. Let me just clear this prism. It is not that great, right? Okay. A ray of light, it's just to show you how the ray of light, when passes through the prism, right, it get refract to a certain angle, then again it get refract here because of the change in the medium. This is air, okay, this is rarer medium, this is denser medium, this is glass, right? And again from glass to air, right? So definitely you will see the change in the path of the ray. Now this is my incident ray, I, small I, and this is my incident ray. And which is this ray, children? Emergent ray, right? If you see, this emergent ray is deviated from the path, whereas in glass slab we have seen that. Let me draw a rough diagram, okay, of glass slab. Little bit like this, and if I extend this incident ray, okay, this is my incident ray and this is my emergent ray. Okay, we have seen in glass slab it is parallel to the emergent ray. Incident ray is parallel to the emergent ray because of the lateral displacement. But here you can see, okay, if I just extend this ray, this is my incident ray. They are not parallel at all. My incident ray is not parallel to the emergent ray. Why this happened? This happens because the two surfaces of the triangular prism, they are not arranged parallelly. Okay children, because they are arranged parallelly in glass slab, rectangular glass slab. That is why the incident ray was parallel to the emergent ray, right? Over here, incident ray is not parallel to emergent ray because of the arrangement of these two surfaces, F1 and F2, which are arranged at a 60-degree of angle, children. Okay. Now, this is because the opposite side of the glass prism where the refraction takes place are not parallel to each other. Very important question. Okay, why the emergent ray and incident ray in case of a triangular prism are not parallel? Okay, so this is the question for that. This is the answer for that. Okay, because the sides of the two because the two faces of the triangular prism, they are not parallel to each other. That is why the angle of incidence is not parallel to the angle of emergent in case of triangular prism. Now let's do the refraction of light through prism, right? So we need to go through this diagram, a very important topic, right? Refraction of light through prism. What we are going to do first, we are going to allow a beam of light. You are going to allow, let me make a cardboard with a small slit here, right? Okay, the slit, the hole, okay, from this hole I will allow a beam of light to go through it, right? This is a beam of light. Have you seen here? PE is the incident ray, right? So P and E, it is a beam of light. It is an incident ray. Here is my prism, the rectangular part of the prism. Okay. So every time you don't have to draw a 3D diagram of the prism. Whenever you have to draw the prism, this will be represented by this triangle. Okay. Now you name the triangle whatever you want to name. A, B, C. Here I have named this triangle as ABC. Right. Now ABC is my triangular prism, and the incident ray PQ is getting incident over here, right? Now this is the surface of my prism. As you know that the outside medium was air. Air is a rarer medium. This is air, and this is my glass, right? This is my glass, and as we know that glass is denser than air, so the optical density of glass is different and optical density of air is different. So whenever the light enter from a rarer medium to the denser medium, what will happen? It will bend towards the normal. Okay, so PE has bent towards the normal. So what you have to do, you have to draw a triangle, then immediately draw a normal here. This is a normal, and N dash is a normal. Okay, this normal is drawn on the surface AB. Clear? Now if you see, this light has bent towards the normal. Okay, this PE has bent towards the normal, right? So this is my angle of refraction, right? So this is bent towards the normal, and it is passing through the prism. Then again there is a difference in the medium. The glass is a denser medium, air is a rarer medium. Here again we have air, which is a rarer medium. So when light passes through denser to rarer medium, what happened? It deviate away from the normal. So my normal here is M and M dash, right? You can see the deviation is away from the normal, right? Here is my emergent ray. This is my emergent ray. Okay, so F and S is a emergent ray. You can see emergent ray, right? E and F is a refracted ray. Clear? Then angle of the prism, this is B, A and C. B, A and C is the angle of the prism. Here is the angle of the prism. This is my angle, right? I will make it theta. Okay. Okay. Now angle of incidence is this, angle between the incident ray and a normal is this, right? So this is my angle of incidence. Angle of refraction is okay, the angle between the refracted ray and normal is angle of refraction, right? Now what comes now? Emergent ray. So if angle of emergent, so angle of emergent is the angle between the emergent ray and the normal, or normal here is m, right? Now what we have to see, it is very important, this ray which is coming out from the glass to air because of the change in the medium. Glass was a denser medium, air is a rarer medium, so this ray is getting refracted away from the normal, right? And let us extend this incident ray. Let's extend this incident ray. Okay, if I extend this incident ray behind, and if I see this emergent ray, and let me extend this emergent ray behind, right? So I've extended this emergent ray behind and the incident ray behind. There is an angle formed here, right? Now this angle is the angle of deviation. It shows that how much the emergent light has deviated from the angle from the incident ray. Okay, how much the emergent ray is deviated from the incident ray. So this is called angle of deviation. So this angle of deviation, this happens, this phenomena is happening just because of the shape of the triangular prism, right? On the two surfaces A and B, two surfaces A and B and A and C, they are not arranged parallelly, but they are making a certain angle over here. Okay, student, and this deviation is responsible for the formation of the 7 colors of the white light. Okay, so this is a very important experiment. So let's see uh, what is exactly happening in the case of the rays. Here is our diagram, the angle of deviation. This angle of deviation, I have taken this topic because a very important concept to understand the deviation, or to understand how the different colors are coming out from your white light. Okay, fine. So this is actually a theta here. It has moved to that side. Okay, fine. The angle of deviation, let's see the definition first. The amount of overall refraction caused by the passage of the light ray through a prism is often expressed in terms of angle of deviation, right? So how did I get the angle of deviation when I extended the incident ray? Here you can see the incident ray is extended. Here you can see the this is emergent ray. After refraction it has bent, and if I extend this emergent ray, here will be the angle of deviation which is formed between the extended incident ray and the backward extended emergent ray, or let's say in a very simple term, incident ray and in emergent ray. Okay, the angle formed between the incident ray and emergent ray is known as angle of deviation. Clear? Now the very important phenomena that we are going to see here. The angle of deviation is the angle made between the incident ray of the light entering the first phase of the prism and the refracted ray that emerges from the second phase of the prism. This is my first phase. This is my first phase, and A to C, this is my second phase, right? So we know that emergent ray is okay coming out from the second phase, and incident the ray is okay emerging from the first phase, right? So this is what we did. Now because of the difference in indices of refraction for the different wavelengths of the visible light, okay, now what is a visible light, right? The white light that we see, that is coming out from the sun, okay, which makes the pattern of Vibgyor, right? All those colors of light, okay, all those color of light, that is Vibgyor, that is formed because of the dispersion and the refraction of white light, right? That is called a visible light, because that is the only light which we can see. That whole spectrum is a visible spectrum, children. Okay, there are ultraviolet rays, infrared rays, UV rays, okay, that is also coming out from sun, but we cannot see those rays, right? So that is why we have given that these type of ray which is visible uh, by our eyes, that is a visible pattern or a visible light. Okay, children, the angle of deviation varies with wavelength. This is very important point. Okay, so the angle, when you allow a light ray, you can see here white light, when you allow the white light, okay, obliquely incidenting, okay, on the surface, the first face of the prism, as you can see these white light, you can see the different colors of waves are coming from these white light. And if you see very carefully, the red light has more wavelength. Just want to revise you one more thing here. Red light has more wavelength. Now what is a wavelength? We did last year, right? It is a distance between the consecutive crust or the consecutive trough, right? So this distance is the wavelength, right? And if you see the wavelength of red light is more, and if you see the wavelength of uh, violet light is less, right? So this distance is less, isn't it? So wavelength of red light is more, it is bigger as compared to the wavelength of violet light, and because of the difference in the wavelength, the deviation is differing in these 7 colors of light. Red light deviate less. You can see here, this is my incident ray, right? And see the red light, how much it deviated, right? And see this, the blue light, or let's make it a purple light, right? And the deviation of purple light is more as compared to the deviation of red light. Okay, here the deviation of red light is less, and the deviation of purple light is more. So the deviation depends upon the wavelength of light, right? Right. Now coming to the dispersion of light, very important topic, dispersion of light. Now this experiment was first done by Sir Isaac Newton. Okay. Newton discovered that white light consists of 7 colors. So this experiment was first done by Sir Isaac Newton. What he found? He allowed a beam of white light, right? He allowed a beam of white light to pass through a hole and to or a slit, and this white light getting incident on a prism, on the surface of the prism PQ. Let's take PQ is the first surface of the prism, right? Let's make it a first surface or the first face of the prism, and this is my F2, the second face of the prism, right? As soon as this white light strike on the point B, you can see this light started dispersing. Okay, these light starting dispersing or deviating, right? Dispersion of light takes place at point B, right? And over here, when this light are striking on the second surface, on the F2 surface of the prism, you can see these are getting deviated, right? If you see, the first light is the red one. Okay, the red color light is deviated least. The first reason which we studied in the last slide was a long wavelength. Okay, long wavelength. For the wavelength, children, you know that we use the symbol lambda. So I have using here lambda. Okay, so long wavelength, less deviation, right? And the second reason, which is very important, the speed of red light. Speed of red light is more, it is greatest. Red light, okay, it let light travel with the highest speed, children. And something which is traveling really fast, is it easy for you to deviate it from the path? No, right? So red light, because of the long wavelength, because of the greater speed, greater velocity, the red light deviates less, children. Okay, so while writing Vibgyor, okay, that this white light, as you see, it has okay, it has dispersed into 7 different colors, right? Dispersed into 7 different color, and let's read the color from the down: violet, indigo, blue, green, yellow, orange, and the red. Okay, from down to up we are going, from lesser wavelength to greater wavelength, right? So here, if you see, if I place a whiteboard over here, if I place a whiteboard, WB, okay, whiteboard over here, I can see the 7 different colors which are coming out from the white light after the dispersion and after the diffraction. So 2 processes are taking place here. At B, dispersion taking place. At this point, there is a refraction taking place, and due to the refraction, which depends upon the wavelength, which depends upon the velocity of the different colors of light, because of that we can see there is a deviation, right? So if I see maximum deviation taking place with violet color light, and the least deviation taking place with red color light, right? So after doing this experiment, Sir Isaac Newton came to the conclusion that a white light consists of different colors of light also, and these colors of light are nothing but Vibgyor: violet, indigo, blue, green, orange, red. But while writing this, it starts from down to up, children. Okay, this very important question. Okay, the which light deviate less? Red light. Which light deviate most? Violet light. So on the top of the spectrum, which light comes? Red light. At the bottom of the spectrum, which light comes? Violet light. Okay, now coming to recombination of a spectrum by Sir Isaac Newton. So what initially, when he found out these 7 colors, he was very excited, right? So what he did, so he kept one more prism. Is first prism he did, he got 7 colors, right? 7 colors he got. And what he did, then he put another prism like this, and he was trying to do few more, trying to find out whether this light is made up of some other or some more color or not, but he couldn't able to make any conclusion because the experiment was not that great. Okay, so so then he decided, oh, let me keep one triangle like this. Okay, so when he allowed white light to pass through triangle, he found that he got 7 colors. Okay, let me draw it properly, because this, okay, he got 7 colors, as you can see here in the diagram, right? So he got 7 colors, 7 different colors, right? Then in the second attempt, what he did, he put another prism of the same configuration, that means another triangular prism, right? And he allowed these light to fall on this triangular prism. But in the second experiment, this is the second experiment, this was the first experiment. Okay, so in second experiment, he put a triangular prism but inverted. As you can see, this triangular prism he put inverted. He kept inverted triangular prism. So this is inverted, and when he kept in a triangular prism inverted, what he found, you can see here children, he found that the reverse reaction is taking place. Okay, reverse reaction. Instead of dispersion, these lights are coming together, right? Instead of dispersion, these lights are coming together, and after coming out from the second surface of the prism, after coming out from the second surface of the second prism, right? This is my second surface, right? This is my F2. He found that this light is nothing but white light. This light is nothing but white light. Okay, I'll write in a short form, right? White light. Now let's see the conclusion part of this experiment. Okay, the recombination. So this is what is called recombination, right? The recombination of 7 colors produced by the first prism. So this is my first prism, is due to the fact that the second prism has been placed in the reversed position. So this is my second prism, which which the Sir Isaac Newton had kept invertedly, okay, in the reverse position, due to which what happened, due to which refraction produced by the second prism also refraction is taking place. A light ray, these light rays are moving from rarer to the denser, so they are moving towards they are bending towards the normal. So due to the refraction produced by the second prism, which is equal and opposite, this is very important, equal and opposite to that produced by the first prism, right? And finally he again got a white light on his white board, right? So this is what happened in recombination of spectrum. Now coming to the rainbow, we have done the dispersion of light, we have done the spectrum of light. Now we are going to see the rainbow. So a rainbow is formed when it is raining at the time of sunshine. So there are certain conditions which are very important for the formation of rainbow and which are very important to see the rainbow. The first condition is rain at a time of sunshine. Okay, or the rain has just happened, right? So there should be water drop. There should be water droplets in the sky. That is the main thing which is important for the formation of rainbow, because these tiny small little water drops, they acts like a prism, right children? So when the white light falls on the raindrop and leaves them, then the white light is refracted and an arc of 7 color is formed in the sky. In this situation, tiny raindrops act as a glass prism, splitting the white light. Children, here I want to tell you one thing. Splitting of the white light into 7 different color is known as dispersion, right? And the band of 7 different color is known as spectrum. Okay. So we can see the rainbow if we stand with our the second condition here, we can see the rainbow if we stand with our back towards the sun. If you see this person here, his back is towards the sun, right? The sun and the rainbow, okay, they are on an opposite side, right? If the sun is on your left hand side, the rainbow is forming on the right hand side. Or let's take, if the sun is on the west, the rainbow is forming on the eastern part of the sky. Clear, student? So these are important points which you should remember. There should be a rain or water droplets. Rain and sunshine should be together, because we can see this rainbow even when we can see a waterfall or when we see a fountain, right? So during that time also you can see a rainbow forming behind in the waterfall or behind the fountain, right? So that is important. There should be water droplets. These small tiny water droplets, they act as a prism, right? Now let's see the formation. A ray of white light, that is AB, as you can see here, AB is a ray of white light, okay, enters the raindrop. Now it enters the raindrop, right? At point B, as you can see here, at point B, what is taking place? Which phenomena is taking place? Refraction. That is, refraction is taking place at point B, right? Fine. And once the light enters, what is happening? Dispersion is happening. So first refraction happened due to the change in the optical density of the two medium, air to water, right? And here dispersion is taking place inside it, right? The light, white light, is dispersing into or splitting into 7 different colors of light, right? So at C, what is happening? At C is happening total internal reflection. Okay, this is total internal reflection, student. So total internal reflection is taking place at point C because of this reflection of a spectrum. Okay, what is happening at point D? Now these different colors of light are passing from the water to air. That means they are passing from the denser medium to the rarer medium. And again we will expect refraction at the point D. Clear, students? And because of that refraction, you can see these lights are deviated. The most deviated is violet and the less deviated is red. Very important. And now a person can see a rainbow. So all these small tiny little drops, okay, they do the same type of phenomenon, and because of that you will see a complete rainbow in the sky. Usually you see rainbow, definitely it is seen as semicircular rainbow, but when you see the rainbow from the sky, okay, usually it is semicircular because there is something called horizon, right? It is horizon is there, because of that you can see the rainbow in a semicircular form. But when you see from the top, if you are on a plane, right, when you see from the top, this rainbow you will see in a circular form. Children, very important, okay, and very interesting also. These are all phenomena you watch, you see usually in your, right, life, but we don't know the scientific reason behind all this phenomenon, and these phenomena are really interesting. And now if you see the spectrum, okay, the red color in the rainbow, the red color spectrum appears at the top because it is deviated less. The red color spectrum appears at the top while the violet at the bottom. This is a very important question, can be asked for 1 mark in case of rainbow, and this diagram is very important. Children, now let's do the question answers. Question number 1. In the figure given alongside, a narrow beam of white light is shown to pass through a triangular glass prism. After passing through the prism, it produces a spectrum Yx on the screen. State the colors seen at X and at Y. So if you see this white light, it has deviated less when it is at Y. So definitely the least deviated light is red in color, right? And the X, as you can see here, it is the most deviated. So which light color is most deviated? Violet light color is the most deviated. And why this deviation happens? This deviation happens because there because they have all the colors of the light, that is 7 colors of the light, they travel with different speed in a medium which is other than air. Children, this is very important point. Lights travels through the air with 8 into 10 to the power 8, 3 into 10 to the power 8 meter per second speed. So all the constituents of white light, that is all the 7 colors, the Vibgyor that we have done, they travel in air, they travel with the same speed, that is 3 into 10 to the power air. But as soon as they enters into a medium other than air, their velocity changes. In case of triangular prism, there is a, they travel with a different velocity. There are two processes happening here, refraction and dispersion, or the splitting of light, right? So this splitting of light takes place because of the different velocity with which these all constituent of white color travels. So the fastest is red, so that deviates less, and the slowest is violet, so that deviates the most. So red always forms upper part of the spectrum, and violet forms the lower part of the spectrum. Now coming to the next question. Okay. So question number 2. Name the scientist who discovered that sunlight consists of 7 colors. We all know that the name of the scientist is Sir Isaac Newton in the year 1665. Question number 3. Draw a diagram to show the refraction of light through glass prism. On this you have to mark incident ray, emergent ray, and angle of deviation. So as you can see here, this light is this ray is incident ray or incident beam. Okay, then it get refracted, and then again on the second surface of the prism it is refracting again, and when it is coming out from the prism, when it is moving out from the denser to the lower medium, it is called emergent ray. Okay, now when we extend emergent ray behind, as well as when we extend incident ray, we are finding that these two rays, incident ray and emergent ray, they are meeting at one point and they are forming an angle, and this angle is angle of deviation. Question number 4. What is a rainbow? What are the two conditions necessary for the formation of rainbow? As we all know, rainbow is an arch of 7 different colors visible in the sky. Okay, now what is the color which is at the top of the rainbow? Red. And which is the color which is at the bottom of the rainbow? That is violet. So that also very important point. The two conditions necessary for the formation of rainbow: sun should be at the back of the observer, and the presence of water droplets in the atmosphere, because these water droplets help work, or yeah, they work as a triangular prism. And because of the three phenomenons uh, which are present in these water droplets, two phenomenons which are taking place in the water droplets, children, we know that it is over here refraction, at this point refraction, right? And at this point there will be a reflection. Here refraction with dispersion. Okay, light get dispersed. Over here at this point there will be reflection, internal reflection, total internal reflection, and again the light will, okay, move out from the denser medium towards the rarer medium. So this is the denser medium and this is the rarer medium, okay, which is air. And when light moves out, it refracts again, and you can see the 7 bands of Vibgyor, that is called spectrum. Coming to the next question. A ray of light breaks up into its components while passing through the glass prism. Okay, draw a ray diagram to show the path of rays. So the diagram is this. So you have to draw a neat diagram of this picture, and this is all students for today's session. Practice today's topic, and thank you so much.